All right, section 6-8 talks about applying coordinate geometry. And really what we're going to do is we're going to kind of extend from section 7, where we look at those polygons in the coordinate plane. We're going to talk about polygons a little more generally. So instead of giving each vertex a specific point, we're going to say, hey, how can we talk about these in a general sense? And that's going to help us with proofs when we do coordinate geometry proofs. So we're really just going to look at some variable lengths and positions for these vertices to be at. We just have a few quick examples to go through here as we'll wrap up this section pretty quick. So as I mentioned, we've talked about polygons in the coordinate plane having specific vertices. Well, we can also use variables to name the coordinates of a figure, and that allows you to show the relationship in general. So in chapter 5, we looked at the segment joining the midpoints of two sides of a triangle, and we called that the midsegment. And here they're just showing you in figures 1, 2, and 3 different ways that they could place a triangle somewhere on a coordinate plane, either up in quadrant 1 or with vertex P being at the origin, or splitting so that vertex Q is on the y-axis and you're split into quadrant 1 and 2. Just different ways of showing you. And then they've labeled their points using what we know about the axis and then some general variables. So for example, this first figure 1 here, we don't know where point P is. It's not on either axis. It's a positive number, but that's all we know. So point P we're just going to call A and B. Now point R is further along the x-axis, so it's going to have a higher x value, but it has the same y value. So they've picked another variable, E, and they've reused point B because we know it's at the same y value as point P. And Q doesn't have the same x nor y as either P or R, so we've given it two new variables, C and D. Now, notice how much easier it is when they've placed point P, like they did in figure 2, right on the origin. P has the coordinates 0, 0 because it is at the origin. Then R, also still along the x-axis, will have some positive x value, but a y value of 0. And then Q, again, has just these arbitrary values, A and B. But it'll be a little bit easier to work with that figure 2 because we have some values that are 0. And another way we can do it, if we look at figure 3, we've placed Q along the y-axis, and knowing what we know about the midsegment, we're able to say that Q is at the point 0 because we have it moved along the x-axis, to B because it's twice as high as our midsegment, and then we've got the point P at negative 2A. We know it's negative because it's along the negative x-axis in quadrant 2, and R 2C 0. So it's nice to have those values we can kind of work with. And that last figure, we've got 3 points. Each of those points have a 0 and 1 on the position. So again, arbitrarily, we can work with these values. So let's practice that. We've got 2 different parts here, part A and part B, and we're asked to name the coordinates of the vertices for each figure. So let's start with part A. And we're told SQRE is a square, so we know that it's got all right angles and that all the sides are the same length. And we're told SQ is equal to 2A, meaning the length of side SQ, that's the top, is 2A. Then we're also told that the axis bisects each side. So what does that mean? Well, we're told a lot there. Let's start with this bottom portion. The axis bisect each side. That means that this y-axis is going right through the middle of SQ. So this portion of my segment here is congruent to this portion. And the same thing is true with QR. X is bisecting side QR. And since my sides are the same length, their bisected sides are also the same length. And we can continue to do that all the way around here. So by placing this square in the coordinate plane the way they've done so, they've bisected my sides and created 8 congruent sides. Now, what else do we know? We're also told that SQ is equal to 2A. So from S all the way to Q has a length of 2A. Well, since we already know SQ is bisected, it's cut in half, each of those halves have to be A, so that when you add them up, A plus A would give you 2A. So from S to my y-axis has a length of A, and then the y-axis to Q has a length of A. And just since all of these sides are congruent, we can do that all the way around. Now each of those 8 congruent sides have a length of A. So the last thing we have to do is give these vertices point values. Now notice point S is to the left of the y-axis, meaning it's along the negative x-axis. So it's going to be negative A units to the left, and we're in the quadrant 2, so my y values are positive, and positive A units up. So S is going to have the point, or the vertex S will be at negative AA, whatever A is. Q is in quadrant 1, that's going to have positive values for the x and the y, so A, positive, positive. R is in quadrant 4. My x is positive, so positive A, but my y is negative, A, negative y. And then E is in quadrant 3, where both x and y are negative, so negative A, negative A. So taking this figure and giving it some arbitrary points so that we would be able to work with this given any values if we knew we had a setup like this. All right, now let's look at B. B says TRI is an isosceles triangle where TI has a length of 2A and the y-axis is a median. Now remember what your vocab term median is. We learned that just last chapter. A median goes from the vertex through the midpoint of the opposite side. So that tells us that TI is bisected by the y-axis. So this side here has to be the same as this. Now, what else do we know? Well, we're told up here that TI is a length of 2A. So just like we did with the square, if that whole length is 2A, and it's being cut into half, each of those halves have to be A. And notice it's along the x-axis, so the y value for points T and I are going to be 0. We have not left the x-axis. So T, since it is along the negative x-axis, it's going to be negative A units to the left and up or down 0. So T is going to have the coordinates negative A, 0. Similarly, then if we look at I, also along the x-axis, but the positive x-axis, so it's going to have the coordinates A, and again, has not gone up or down along the y-axis, 0. And the last thing we need to look at is point point R, along the y-axis. We know it hasn't gone left or right at all since it is staying right on the y-axis, so it's going to have a x-coordinate of 0. And how high it is has no relation to the position that T and I are at. So it's going to be a different value altogether. So we're just going to give it a new value variable, and we're going to call that B. You could call it D or you could call it Q. It's possible it's the same position as A, but we don't know enough about that, so we're going to call that B. So again, taking a triangle and giving it using only 2 variables, A and B, and 0, given the points and vertices. So last example we want to look at says the diagram shows a general parallelogram, so we do know it's a parallelogram, with a vertex at the origin and one side along the x-axis. So it's just explaining to us what we see here. We're asked what are the coordinates of D, the point of intersection of the diagonals of parallelogram ABCO, and how do you know? Well, let's think about what we know about a parallelogram. In a parallelogram, one of our properties is that the diagonals bisect each other. So since the diagonals bisect, D is the midpoint of those two diagonals. So point D is at the midpoint of AC. It's also at the midpoint of OB. So you can use your midpoint formula, and you can use either point AC or you can use either sides AC or OB and plug in what you know about the midpoint. So D, I'm going to use AC. I'm going to say D is equal to the midpoint of AC. And just remember your midpoint formula if you need to go back to section 7 to review. So A has an x-coordinate of 2A, plus C has an x-coordinate of 2B, all divided by 2. A has a y-coordinate of 0, plus C has a y-coordinate of 2C, all divided by 2. Now, let's start by simplifying my x-coordinate, 2A plus 2B. I can't add those, they're not like terms, But notice they each have a 2 in them, and I'm dividing by 2. So that 2, since it's in every term, cancels, and I'm left with a plus b for my x-coordinate. And 0 plus 2c is just 2c. 2c over 2, again a 2 in each term, I'm going to be left with c. That's all they're looking for here. Can you manipulate when you don't have exact values? Can you still use those formulas? And you'll see that come into play in your homework as well.